Okay, welcome, Eric and Sammy and Nick, and connected to, I'm not sure who. Thanks for coming. This is actually the very last webinar of the entire class. So hopefully you've learned a lot in the class and you're ready to finish it off. Let me share my desktop and I'll talk about what we're doing today. Okay, the plan today is, as always, we'll start out with Q&A if you have any questions. If it's about the final exam, you probably want to wait until we have the final exam discussion, but about anything else, I'll answer questions. And then after that, it's the very last hypothesis test of the entire class. Doesn't mean there are no other kinds of hypothesis tests, but we can only do so many. And what we're doing today is we're doing ANOVA. Okay, ANOVA actually stands for analysis of variance. But unfortunately, it's really not about variance when it comes to what we're trying to do a hypothesis test on. It's about means. So it turns out that it's something that we have not yet done, and we have not learned how to do that. And ANOVA is really important. So we're going to get into that and talk about how to test for many means. Then I'll talk about assumptions you need to be able to do ANOVA. I want to give you a little warning, and that is you're going to feel like you've got ANOVA down and you're ready for it, and you'll get into your upper division coursework and you're ready for ANOVA, but you won't be after today. We're just going to touch on ANOVA. ANOVA is really deep, and I'm going to say a lot of things. Well, here's an assumption, but you're going to have no idea how to decide whether the assumption's right or not. That's the hard part about ANOVA. So we'll get into just how to do ANOVA, but the assumptions, I'll list them, but I'm not going to explain how to detect whether they're correct or not. And then we'll talk about the final exam. So the final exam is coming up soon. So just let you know, Sunday's your first opportunity, and then Tuesday and then Wednesday are the last opportunities to take your final exam. And just like the regular exams, you get one shot. So you choose which of the shots you take, do that, and then the course is over. And then call it a day, or call it a quarter, I guess. So that is the plan for today. Let me ask you, are there any questions about anything other than the final exam, which I'll talk about in a little bit? Any questions? Any questions? Give me a minute to think about it. Oh, I didn't do my chat. Let me find it. Okay, any questions? Okay, if there's not any questions, I want to talk about ANOVA. And just want to remind you, as always, if you have questions come up, ask whenever you want. It's not like I have to ask you if there's questions. Just that's the great thing about the webinars is you can ask anytime. So we have learned a lot of different types of hypothesis testing, and I think it's worth it to go through them now, because you got to get these down for the final anyway. So it's part of the final review, and then I can talk about what we haven't done, and we'll do at least one of the ones we haven't done. So the first kind of hypothesis testing we did is we looked at two population means, and we wanted to say, a single population mean that we didn't know about, and we wanted to say, is it bigger than a certain number? Or is it smaller than number? Is it equal to number? That was a hypothesis test for a single mean. Then we did the same thing when it wasn't means. We said if it was a yes/no question, then we were able to do a hypothesis test for proportion to say, well, do the majority think this, or does fewer than 20% think this? Okay, when it was a yes/no question. Then we went ahead and we bumped it up to, instead of a single mean, to two means. And we compared one mean to another mean. And we looked at, say, are men taller than women on average? Okay, and that was a hypothesis test for a difference between two independent sample means, but we also looked at dependent. Dependent, if you remember, was when there were either two answers to a survey question, and we wanted to see the difference between those. So we can subtract the dependent because every person has two answers. Or maybe we're going to be looking at the same day with two different events that happened during that day. That would be dependent. So there are lots of different dependent kind of samples. And then we did a hypothesis test for dependent samples, okay, sometimes called paired data. Then we also looked at a hypothesis test for the difference between proportions. So we might say, well, you know, is the proportion of Democrats higher than the proportion of Republicans that are ready to get vaccinated? Okay, and that would be a difference between two population proportions. Okay, so that was the next one we did. We did a lot of hypothesis tests in this class. Okay, then after that, we moved out of the quantitative or yes/no questions, and we talked about chi-squared. So we had 3 different chi-squared tests. One was goodness of fit, and that was when you have a qualitative data, and you want to find out if the distribution of the data follows some expected distribution. That might be normal or uniform or some known thing from the past. Okay, those are the typical expecteds. Then we also did test for homogeneity. And that was when we looked at, instead of a single qualitative survey question, we looked at 2 qualitative survey questions. And we wanted to compare the distributions for the 2 qualitative survey questions to see if they were the same or different. And that was test for homogeneity. And then we went and looked at the test for independence. And that was when you want to you have basically 2 qualitative survey questions, and you want to find out if one is independent of the other. Okay, and then we moved to regression analysis. And that was when we wanted to find out if there was a correlation between 2 quantitative dependent variables, or was there no correlation? And that was a hypothesis test for that. And now what's left? So what haven't we done yet? What don't we know how to find a hypothesis test for yet? And there's more than one, but we're only doing one today. And then we're not doing the rest of them because this class can only do so much. So what haven't we done yet? Can you think of what we don't know how to do a hypothesis test for? Looking at the chat box, not seeing a lot of answers. Here we 2 qualitative variables. Actually, we do know how to do 2 qualitative variables. Test for homogeneity, for example, or independence is for 2 qualitative variables, right? So if you want to find out if you're talking about whether the 2 qualitative variables have the same distribution or if they're independent, we know how to do that. Now, there's some things we don't know how to do with qualitative variables. And that is things like if we find out they're dependent, then you say, why are they dependent? That we don't know how to do yet. Or if we find out they have different distributions, you find out, well, how are they different? We don't know how to do that yet, and we're not going to learn how to do that in this class. But there are ways of doing that, different tests. So you're kind of right with the qualitative variables. We know how to do some things with them, but not others. So what else? Any ideas? Don't see you all jumping in. So we talk about things that we don't know how to do and we're not going to learn how to do in this class. And that is, for example, are the standard deviations of 2 variables, 2 survey questions the same? We haven't tested standard deviations being the same or not. Okay, you do the same thing with variance. We haven't tested that. We have not tested for medians. So is the median home price the same in Tahoe, for example, as it is in Sacramento? Right? We have not learned how to do that. Okay. We're not going to do that. Okay. Can it, do you think it can be done? What do you think? Yeah. Yeah. What do you think you have to do? What do you think you have to do if you want to learn how to test for two medians? Any thoughts? Don't see y'all jumping in. You need to take another statistics class. That's what you need to do. You need to get into a university, take an upper division statistics class, and then you'll learn all those other things I'm talking about. Okay, so all this can be done, but again, I like to kind of give you a heads up of what we don't know, but these things can be done. You just need to take more stats. So there's a lot more stats to do. Okay, I can go on and on and on, but Eric gave a suggestion, and that's what if we have more than two different means that we want to compare? So we've learned how to find the difference between two means, whether the two means are the same, but what about three means? What if we want to find out whether three different means are the same, or maybe 10 different means? Okay, so for example, is the average income the same in all 50 states? Do we know how to do that? Okay, we don't, but the good news is we will today. So that's our last type of hypothesis test. And that hypothesis test is going to be called ANOVA, ANOVA. And that is comparing for multiple means. And I have an example. I'm not going to spend the whole day on this. It's just one, it's not a hard test for what we're going to learn in this class. So I don't do all the details, but I want to make sure I get to a good portion of the class talking about the final. But I do need to talk about ANOVA, and ANOVA is a biggie. Okay, it comes up a lot in especially psychology. I think they're the ones that do ANOVA a lot, but other places also. So here's an example, and it says, "Is race a factor in GPA?" Okay, so that's pretty important. Colleges are definitely looking at those kind of things, whether, we need to focus on making sure we have equity and all that, to make sure that, no matter what race you're in, you have a good potential of making it through. And we're going to do what we can to make sure that everyone has that opportunity. Okay, because that is important. Okay, and below are the results of a study that was done. And you've heard this disclaimer before. When I say below are the results of a study that was done, what do I really mean?
Is it made up statistics?
Exactly. I made up some numbers. I put some numbers in just so that we could do it. But could you imagine doing this study? That this study could be done by a college? Yeah. This is definitely a study that could be done. But I decided to make up numbers for one reason or not. And I decided to break it up into Hispanics, Caucasians, African Americans, and others. So what we have not learned yet is how to do this, to decide whether race is a factor. And that's the same thing is saying is that are all the population mean GPAs the same for each of these four types of races? Okay. And I just put other as a conglomeration of everything else. Any questions on that idea? Okay. One thing we could do, but it doesn't work, and that is we can compare Hispanics and Caucasians using a test for two means. And then we can compare Hispanics and African Americans. And then we can compare Hispanics and other and just do every pair. And if any of them are different, then we say races, they're not all the same, right? We've talked about this before. Do you remember what the problem is with doing what I just said? There's a big statistical problem with just comparing every pair And then if any of those reject the null hypothesis, then you say they can't all be the same because I found two that are different. But there's an issue, a big fat issue. What is that? You remember? We talked about it 2 weeks ago. Okay, the problem, since you're not remembering, is that for each hypothesis test you do, if you're using, say, a 5% level of significance, then if they were all the same, there would be a 5% chance of a type 1 error. Now, it turns out there are 6 different hypothesis tests you would do. There's 6 different pairs. You can trust me on that, or you can do the counting. There's 6 different pairs of to do, so there'd be 6 different hypothesis tests. So you'd have close to a 30% chance of a type 1 error. And that's not acceptable. Okay, so what you don't want is to explode the type 1 error issue. So this ANOVA, and as always, I'm not going to get into the deep mathematics, but there is some deep mathematics that go into this that deal with the exploding type 1 error issue. And you can just trust the statisticians that they made it so that with ANOVA, it's not going to explode. Okay, that you can do even like all 50 states and find out that GPAs are different in the 50 states at colleges. And that would be thousands of different pairs that you could do. And that would be ridiculous explosion of a type 1 error. But ANOVA handles it. Okay. And again, the last thing I'm going to do is explain the math. So what do you have to do if you want to learn the mathematics behind ANOVA?
Take more math classes.
Yeah, I would say more than that. You need to get a graduate degree in mathematics. Undergrad's not even enough. You need to take a lot of math classes, not just like 5 or 6. We're talking 30 math classes. So no, you're not going to learn how to do the mathematics of ANOVA unless you decide, like me, you're a total nerd like I am, and you want to do that kind of stuff. Most of you probably don't. But instead, we're going to do ANOVA. So let me write that down. So ANOVA, and let me tell you again what it stands for. Analysis of variance. So ANOVA is an analysis of variance test, and be careful, that does not mean we're testing to see if the variances are different or the same. It just means that in the deep mathematics behind it, the variance happens. You never have to know about that. All I want you to know is the word ANOVA and analysis of variance. Okay, so don't worry about why we call it analysis of variance. Any questions on that idea? Okay, so the first thing is, again, it's analysis of variance, and it actually uses a distribution that we haven't learned yet. And it uses the F distribution. Okay, what distributions have we, because this is our last one, by the way, since it's our last thing we're doing in the entire class. See if you can list all the distributions we've learned, because you are responsible for remembering what the distributions are. There's a lot. Maybe each of you can put one in the chat box. And that may still not be enough. Good. Normal, uniform, good. There's others. A lot of them. There's one that's the easiest to type of all of them. Okay, binomial. That's a good one. Not the easiest to type, but a good one. It's a longer word. So what else have we done? Probability is important in statistics, but it's not a distribution, right? It's a statistical idea, but it's not a distribution. Okay, it is important that you kind of remember them all. Good, the T distribution. So T, that's the easiest to type, right? So T is one letter. If you want to write the full name, it's a student's T, but T is good enough. I'm surprised you're not getting the most recent one we've done that we learned. before F. Which is very important. No numbers? Z is the letter used for normal, so we already did normal. Remember? If you don't remember, chi-squared, does that ring a bell? Yeah, so chi-squared is the other biggie because we had a whole chapter on that. That was chapter 11. And we did the chi-squared good as a fit, chi-squared homogeneity, and the chi-squared independence. Those are all the chi-squared distributions. Okay, but the ANOVA uses what's called the F distribution. And again, the last thing you want me to do is get into the mathematical details of the F distribution. I'm sure my guess is you all agree with that statement because it's brutal. But I will tell you that there is such a thing. And you get a curve and same idea. On the curve, there's going to be a test statistic. To the right of that test statistic, the area to the right will be the p-value. The same stuff we've done all along in the whole course. So I'm going to kind of skip all that because you're not going to be responsible for knowing all the details. But just in general, you should know this idea because that's what we've been doing all, for the last 5 weeks or so, or 6 weeks. Okay, so we now have analysis of variance. It uses the F distribution. Okay, so now that we have that, what's the next thing we should do when it comes to hypothesis test? Again, you should all know this. If you can't do this, then you're not going to do well on the final. Right? In order at which you do things in a hypothesis test. What's the next thing? Ask the question, which I already did actually. So that was the previous thing. See, is race a factor in GPA? That was already done.
So come up with the null and alternative hypothesis.
Exactly. So the next thing we do is come up with a null hypothesis. And then after that will be the alternative hypothesis. Again, at this point, it's really important you know the order at which you do things. And that's definitely the next thing you do in every hypothesis test, right? So let's do that. So I am going to there it is. So we're going to have H naught. And then colon. You better be used to H naught colon because that happens in every null hypothesis. And now let's see what we're doing. We want to see whether the means are the same for all 4 of these, right? So hopefully you better at this point, all of you better know the symbol for mean, which is?
Mu.
Mu. Okay, so mu, and I'm going to write mu sub h. And if they're all the same, then it should be an equal sign. And then that should be equal to mu sub c. So H for Caucasian. H for Hispanic, C for Caucasian. And that should be equal to mu sub A. For the African American mean GPA. And that should be equal to mu sub O for other. Any questions at all on the null hypothesis for analysis of variance? Okay, the next piece is a little bit challenging. What is the opposite, right? So remember, the null hypothesis is what you're trying to show is wrong. So if the null hypothesis is wrong, if we do not have that mu sub h equals mu sub c equals mu sub a equals mu sub o, what does that tell you about the means?
They're not equal.
So does that mean that they're all different from each other?
No,
What does it mean?
they're all not the same.
Oh, but all not the same is the same thing as all different, right? Not the same and different are the same things. Yeah, at least one, and I like to say at least one pair. So it could be that the mean for the Hispanics is the same as the mean for Caucasian. But maybe the African Americans do better and they have a higher mean GPA. And maybe they're the same as the others. So maybe there's two paired, and that's still not all the same. Do you see that? They're not all different, but they're not all the same, and that's still not all being the same. Now, what I have learned, I learned it the hard way. And the hard way means I used to symbolically show everyone how to do, they're not all the same. And what I learned is 80% of the class couldn't understand what I talked about. So that didn't work. So as a teacher, you gotta adjust. If no one can understand what I talk about, I gotta find a way that is understandable. So let me show you the way I have found that's understandable, that most people can handle. Still, the beginning, of course, you should all be able to handle. H's the one. So, or A, you choose. So the alternative hypothesis with a colon. And now comes the interesting thing is with ANOVA, the easiest way of doing it is to use symbols for H naught and to use words for H1. And the words you can say is at least 2 of the population mean GPAs differ by race. Okay, again, there is a symbolic way of doing it, but most people don't understand it. It's too fancy looking. So I recommend that H naught should be done with symbols. That's required. And H1 you can do with words. Any questions on H naught and H1? Any questions? Okay. Again, that's different. H1 saying at least 2 are different is not the same thing as saying they're all different. Because you can have the first 2 the same and then the last 2 different. Okay, you could have all kinds of different weird combinations. So it just is at least 2 of them are different from each other. Any question on this? I do want to note one more thing that we've seen many times in this class, population mean. What happens if I don't see those words on your final exam?
Take off points.
Yeah, and I want to let you know, it's going to happen. Population mean, population proportion is going to happen more than once on the final exam. And so it'll be awful if you have to lose points more than once, because that's even worse than losing only a little bit. So get used to writing population mean and population proportion. Okay. Okay, and that was true on your project too, right? You had to do population mean, or I took off points. Same thing. Any questions on the hypotheses, the null and alternative? Okay. Usually the next step is to decide on a level of significance. In this case, what do you think you would choose?
Maybe 0.05.
Yeah, this is sociology, right? This is a sociology example. Sociologists pretty much always use. I've never seen them use anything but 0.05. So I think we could safely use 0.05 as the level of significance because, again, it's sociology. Everyone good with that? Okay. So what's the next step?
Calculator.
Yep, we can go to the calculator. So now I'm going to go to the calculator. Let's see, that might not be the calculator. Let's get the calculator. Actually, that is the calculator. I can go that one. Believe it or not, I'm programming another calculator, not for you guys. I'm giving a conference and I'm having them do some fancy expected value. These are professors' problems. And for gambling. Back to the calculator menu. All right, here's the thing. This is our last webinar of the class. Where do you think this calculator is going to be?
At the bottom.
Yep, there it is. Okay. And again, I tried to make it easy. It's in order, if you remember the name of the test, and it should be clear that it's the bottom, ANOVA, because this is the ANOVA test. Any questions on that? Okay. So the way I program this is to separate the numbers by commas and put them in. So that was the first one. And now let's go back and forth. Caucasians, it's this guy. Okay, and I recommend, by the way, on an exam, for example, copy and paste if they're separated by commas, because it serves a lot easier. Oops. Let's go to African Americans. And let's go to others. By the way, do you need to have the same sample size for each of the groups?
It doesn't look like it.
No, this example did it on purpose because I wanted to kind of emphasize the fact that you don't need the same sample size. Do you think the sample size is large enough, by the way? Like for reality?
No.
No, definitely not. You guys at this point should all know that if you see a sample size of any of these individuals of what, 6, that's not big enough. I did 6 because I don't want to spend all day long doing, huge lists of numbers and all that kind of stuff. And it's too hard. So this is just for a class demonstration. In the real world, we're talking about big sample sizes. So if you're going to be doing this example, if you're going to have over 30 of each, that's what, 124 total. That'd be a lot. Okay, you can imagine if you did by state, then you're going to talk about 50 times 31. That's 1,550 in your sample. It's a lot of work. So ANOVA can be a lot of work because you need, big samples. You need decent sample sizes for every group. And that's hard. Okay, hard as in it takes a long time to do the surveys. But I got lazy and I just did, small samples. So don't follow my cue when you're doing this for your profession. So I want to give you the big warning. Okay. And then I just hit calculate. Okay. And you'll notice it has a letter F. And hopefully, since it hasn't been that long already, what is F? F is the 2 words.
A test statistic.
Yeah, F is a test statistic. Okay, so F is a test statistic. And you better know what P is, since that's happened on every hypothesis test. And in particular, take a look at this P. What do you think?
It's high.
Yeah, there's a high P. Okay. Okay. So does that mean, by the way, that race is not a factor? Population means all the same. What do you think? We got a high p-value.
You would fail to reject the null hypothesis.
Yeah, you can't say race is not a factor. Okay. because what it might be is that we just had too small sample size. When you have a small sample size, you almost always get a big p-value. Okay, even if H1 was correct, with a small sample size, type 2 errors happen a lot. Okay, so that's just a note. Do not accept the null hypothesis ever. Okay, but what we can do is at least we can copy and paste. How about these 3 digits? And write down the test statistic. Was F was equal to 0.869, and the p-value was equal to, how about 0.4713? 0.5 is about what it is, but copy and paste makes it easy to type it. Any questions on that? Easy enough? Okay, so now that we've done that, now we can state our conclusion. So hopefully you all know that it starts with there is. And then what? What's the next 2 words?
Insignificant evidence.
Yeah, and I'm going to write statistically. Insignificant evidence to make a conclusion, or even to conclude. And the good news about having H1 in words is I can copy and paste. And since your final exam is going to be, and everything else you do is on the computer, you can copy and paste too. Okay, so there is statistically insignificant evidence to conclude, I guess that is better, that at least 2 of the population mean GPAs differ by race. Okay, sometimes you'll also hear people say there's insignificant evidence to conclude that race is a factor in GPA. Okay, so I'm going to write that out because that's used a lot. Okay, so that's equivalent in terms of meaning, but I want to let you know that this is said a lot. So conclude that race is a factor in population mean GPA. There's kind of 2 ways of stating the conclusion. Any questions? Any questions on this idea? Okay. What if we got a p-value of 0.01? What would be the difference? How would that change things?
Strong statistic. I don't know. 0.01.
Yeah, 0.01.
It would be less than.
Yeah, so then you would say there's, as Genevieve said, there's significant evidence, statistically significant evidence. So what would change is the IN would go away. And I want to mention, this is really important. If we found out that the p-value is really small, does that tell us which of the GPAs are different? Because H1 is at least 2 of them differ.
No.
No, it doesn't. Okay, is there a way of doing a test to find out which of the 2 are different? Which 2 are different? Any guess?
Separate test for each race?
Not quite. Good try. So it's a question I didn't expect any of you to be able to say more than yes or no, by the way. So your answer is yes, that was correct. Not separate test for each race. But what I will tell you is there is a test. It's called the Tukey test. And but I'm also going to tell you is we're not doing it in this class. So today is the day to advertise for the next statistics class, which isn't at our college, by the way. Okay, but if you get a master's, you may have to learn this stuff. Just let you know that. So that's a typical master's level to learn how to write a thesis. That's the kind of stuff you have to know how to do. Okay, but we're not going to do that in this class. Got it? Okay, so, but I will tell you that just about anything that you can imagine testing for, statisticians have already come up with a test for. Okay, and for just about everything. So that's an example where, yeah, a test has been come up for, but we're not doing it. Okay, but it is used, just not by us. We can only do so much, right? One thing I'm not hearing from anyone is we're not doing enough in this class. No one's complained about that. So, but like I said, I have to restrict. And to let you know, just so you're not mad at me, I go to a lot of conferences and I talk to all my peers, all the other statistics teachers throughout the California community colleges. And I make sure that I do what everyone else is doing. Okay, or I try to do what if over half the people are doing something, then I do it. That's kind of my little, decision, and then I make you do it. So I hope you understand that that's a reasonable way of doing things. But I do collaborate with lots and lots of other professors. So it's not just me being evil. There's a lot in this class. Okay. Any questions at all on this ANOVA example? Okay, so now I want to look at what we've done and say that were we allowed to do it? Are there issues? Okay, so we did an ANOVA, and as you're used to, are there assumptions, or there things you have to do ANOVA that maybe we did or did not have? Any questions on that idea? So let me write down requirements for ANOVA. All right, so for example, the requirements to do a how about a one sample test for proportions? Okay, remember the sample size. This is important for the final, so I'm not just bothering you, hopefully. But there was a sample size requirement. What was the sample size requirement for proportions? If you do a one sample test for proportion? No, please do not do 31 with proportions. That'll kill you on the final, or at least it'll lose some points. Do you remember? It happened a lot. We've done it more than once. Yeah, greater than 5, and not the sample size, but the number of expected yeses and the number of expected no's. So NP and NQ have to be greater than 5. Okay, so that was a requirement. And then remember, there was a requirement for everything. For everything we do in this entire class, what's a requirement? And the hint is we learned about the first week of class. So now more review for the final. Do you remember? For every hypothesis test, and we learned about in the first week of class. Very important. I don't see y'all jumping in. Okay, maybe I'll tell you. Okay, you have to make sure that there's no bias. So you have to do like a simple random sample, or at least a stratified or cluster sampling. So you have to do a good sampling technique so that your sample is representative of the population and you don't have bias. Does that make sense? Okay, and that's true of everything we've done in class. If you have bias, then you really can't say anything. So that's kind of the number one thing in statistics, and that's why we started with it. Okay, so just a note, I just want to remind you of some of the requirements. So now I could write down the requirements for ANOVA. So the good news is one of them is no bias. So that means that the samples were representative of the population. Maybe I'll write that down. Any questions on that? Any questions? Okay, so you probably wouldn't go into some kind of remedial English class and look at GPAs because their GPAs are probably lower, okay, on average, that kind of thing. You're going to go to just, you want to make sure you're representative of the whole population, okay, or you're not going to just look at, I don't know, the Hispanics that got into UC Berkeley. That'd be really biased because they're going to all have super high GPAs. Okay, does that make sense? So you're going to want to make sure that you have a representation, a good representation. Okay, so no bias. Okay, and then the next one that you're used to is that you have a normal distribution, and I'm going to write all the sampling distributions are normal. Okay, so by the way, for our example, do you know that there's no bias in picking these numbers?
No.
No, in fact, I made these numbers up. This is about as biased as it gets, right? I cheated. Okay. Is the sampling distribution a normal distribution? Do we have an assurance of that? See if you can remember. What do you need for the sampling distribution for this example, say for Hispanics, that's the first one. What do you need for that to be the sampling distribution to be normal?
Greater than 30.
Greater than 30. Is it true in this one?
No.
No, definitely not. Which means that you need to make sure that it's true, but are GPAs normal? No. So again, this is an example of never do ANOVA on this because of all the bad assumptions. Does that make sense? So let me put a note. That means all sample sizes greater than 30 or known normal distributions. Any questions on number 2? We're used to that one, right? Okay, number 3 is a new one, and that is the standard deviations. For each of the populations are all close to the same. Okay. By the way, do we know that for this example? The standard deviations of GPAs for Hispanics, are they the same as Caucasians? Do we know that's true? And are they the same as African Americans? Are they the same as other? The answer is we have no idea, right? Okay. So number 3, we've never talked about in this class. And I will tell you, which kind of the theme of today is that to decide whether standard deviations are all the same, you need to take the next statistics class. It's more advanced than we can do. Okay, and I'm sure you believe me on that, right? Okay, so the next one, again, there's a bunch of assumptions. So the next one is a little easier, and that is the sampling was done the same for each of the samples. So the idea on that is you're going to write down the survey question. And the survey question here would probably be, what is your GPA? So we have to make sure is that you use the same survey question for all 4 groups. And I'll tell you in practice where this becomes an issue is, let's say you're going to, let me do this. Let's say GPAs by state is a little easier to understand. You can't go and do it yourself. Okay. You have a lot of funding to do this project and you can't do it yourself. So you hire people, maybe a couple people in each state. And you got to make sure that before everyone goes out and does a survey, you have a meeting, a Zoom meeting probably, because you don't want to pay for them all to come to, your area. You have a Zoom meeting and you talk about how to ask the survey question, and all the different issues, and everyone should be doing it in the same way. Does that make sense? Okay, so that's how you make sure that the sampling is done. It's not that hard, but you just got to remember to do it, especially if you have a staff of people and they're all conducting the research in different areas. Then you have to make sure that they're doing it in the same manner, or that's wrong. Does that make sense? Okay, so again, we have a lot of assumptions, and these are hard. Okay, these are tough, all of them. Number 4 is a little easier than the rest. Okay, there's actually one more, and that is the samples are all independent of each other. So for this example, that's easy. I can't imagine doing a dependence thing. So the issue that you could get if you did like men versus women and you did some kind of phone survey, you can't ask the guy that answered the phone saying, can I talk to your wife? Because now it's dependent. Do you see? So you can't just do spouses, for example. You have to just do just people randomly. Any questions on that idea? Okay, so that's ANOVA. Any questions at all about anything about ANOVA? Okay. The hardest part about ANOVA is the part I don't test on, and that is doing 1 through 5 properly. Okay, I test on knowing 1 through 5, but I don't like make you go and do it as a project. Okay, but I do want to give you the warning that when you get into your upper division work, if you're going to do ANOVA, 1 through 5 are hard. And then you got to do it properly if you're doing real research. Does that make sense? Okay, so this is all, this class is just, in-class stuff. Like your project 2, you're allowed to use convenience sampling. I do want to warn you, don't do that when you're doing your own research someday to like learn about stuff. Don't do convenience sampling. I let you do convenience sampling because I didn't want that to be the hardest part of the project. So real important. So the good news is we're done. So everything that you are responsible for this class has been at least delivered to you. Hopefully you've learned it too. And the next thing after, of course, you got to complete the assignments. Okay. Oh, I want to mention something for the discussion post assignment for this week. There is no excuse for not getting 10 out of 10. Anyone look at it? I know actually some people have done it already. Some people did it yesterday. Do you agree there's no excuse for not getting 10 out of 10? Okay, because I don't ask for any math. Okay, so, and I do want to let you know, because I'm noticing already, you don't need to type in, I'm working on this, because for the discussion post this week, you're allowed to answer more than, you're allowed to reply to more than one person. And you're also allowed to reply to something that someone already has replied to. It's nicer if you see someone that hasn't been replied to reply to them also, because, you're being nice to each other. But you don't need to say I'm working on this, because then you're saying, please don't touch this one. But you're allowed to have, you could reply to everyone's. That's fine. Unlike all the rest of the discussion post assignments where it was a one-on-one, this one's not. This one's not. So again, you can comment, to how many you want, as long as it's at least one person. Okay. But I do want to let you know, that one, it should be an easy assignment, relaxing, be nice to each other, be polite. So don't reply to someone saying, I really hated everything you did in this class. You were evil. Don't do that. Okay, be nice to each other. Okay, that's the one thing I ask for. But other than that, please do your discussion assignment. It's easy. It'll take you not even 5 minutes. Okay, no research or anything. So that's just a note. So as I mentioned, the final exam, you could take it Sunday, Tuesday, or Wednesday. And I'm going to move into the final now. So I think to do that, I'm going to do, the first thing I'm going to do is I'm going to go to the syllabus. Okay, and then I'll get into some of the details, but I want to talk about the final in general, and then we'll get into details. Okay, actually, before I do that, let's do this. Since I don't think anyone's going to log off when I'm about to talk about the final exam. Let's do the secret word. So the secret word for this week is what I want to tell you, all of you who are listening and being polite. I haven't had any evil people in this class, which is fortunate. Usually I don't. And that is thank you. So that's my secret word to you, and that's what you type in for the secret word. If you can't remember that, then I don't know, write it down. So there's your secret word for the time. And again, that's because we're done now. At least we're done with new material. Okay, so now what I want to do is go to the syllabus. And I want to remind you about a few things about the final. So the first thing is the final, again, is on the 21st, the 23rd, or 24th. You choose. It's totally up to you. Just like the regular exams, you take exactly one. And they start at various times, and make sure you can make one of the times. And they're 2 hours. So just the same as regular exams. I try to be consistent. I think that makes the class easier. So they're just as regular exams. The one big, gigantic difference between the final exam and the regular exam is right here. And that is, it's a big part of your grade. Take this one extremely seriously. So I want to let you know the homework assignment this week, or the, I don't know if you call it homework, the chapter assignment this week, that shouldn't take very long at all. That's short. The discussion post should take 5 minutes. So again, this week is all about the final exam, and then a little bit of ANOVA, but the final exam is the main thing to focus on. And it is 30% of your grade. Okay. By the way, no one is coming in with 100% on everything so far, which means if you don't take the final, you cannot pass this class for everyone. Because if you lose 30%, that puts you at 70% minus whatever else you've lost. And everyone's lost at least one. I think I do have a 99, but that's still 69%. So you have to take the final exam. Got it? Okay, so make sure you're ready for it. And then hopefully we're getting some weather, which is interesting. So hopefully the weather's fine. Now where you are, if you're not in Tahoe, that might be different. But we've been getting some weather. We had snow last night. We got some more predicted. So hopefully there's no issues with electricity. If there is, let me know and I'll see what I can do for you. Okay, because that would suck, right? So, but let you know, it's a biggie. Take it very seriously. I would study many hours for this. And when I say study, I mean practice. And I'll show you how to practice. Okay, now let's go to the exam policy, because there's another big difference between the regular exam and the final exam. And that in the final exam, you get a whole page of notes, front and back. Okay. You can fit anything. I mean, I wouldn't say everything in the world on a page, but you can definitely fit enough information for anything you need in this class. Okay. Don't assume that if you've written it down, you understand it. Make sure you practice. So what I recommend doing for this final is start by writing this note page. Leave a little blank so that if you realize while you're practicing that you need to put some more on, then you got some space to do it. And that way, when you're practicing, you got that page in front of you and you're used to it. And because when you have a full page front and back, navigating could be hard. Whereas with a 3x5 note card, navigating is easy. So that way you're practicing with your full page. And when you're looking for something, you don't have to spend a lot of time looking. Does that make sense? So again, so you want to practice with that full page, front and back. Any questions on that rule right there? Okay, and again, that should be plenty of space. Okay, so the other thing is that if you happen to have a disability and you have special accommodations, you need to send me an email to let me know what day you're taking it and what time you're starting, and I'll make it work for you. But if I don't know to make it work for you. So you have to tell me. Okay, and then I'll do it for you. It's no problem, but you have to let me know. And the DRC has notified me of everyone who gets accommodations. So that's already set if you have a disability. Okay, and it's all, I don't talk about names or anything like that because that's all private. And that's why you email me. You don't post that on the Q&A form or something. Just send me an email. Okay, any questions at all on the exam? Okay, I will let you know if all goes well, I'll have it graded by a week from Thursday. So your exam should be graded by a week from Thursday. In other words, the day after the last day to take the exam is when I should have the grades done. The only thing that could be a disaster is, I mean, there's a few things, but the main worry is weather. If my internet goes down, I can't post your grades. So let's hope we don't have like 10 feet of snow that Wednesday and Thursday or something. That happened once in my career where we had to cancel the exam for that. Okay, and then last year I had to cancel some exams because of COVID. Okay, any questions on that piece at least?
I have a question. If we're able to make sure that our computers got the right settings for Proctorio before the exam starts.
So one thing I did, and hopefully it worked, because again, this is one of the frustrating things for me. They don't let me test it. Only students can test it. Isn't that weird? I don't have access to Proctorio to look to see what it looks like. I don't even know what you're looking at. But what I did is, remember that Proctorio practice exam? That was like for exam 1. Do you remember that?
Okay, yeah, I didn't take it, but
okay. Well, I set that so it can be taken unlimited times. I think I set it at 99 times or something, whatever the max was.
okay.
So you can definitely test that way. And that's no guarantee, because you know how it is. The bad luck happens, and for some reason it works, and then it doesn't work the next day. And I can't do much for you on that. The other thing I want to remind you, there is no access code. Proctorio has this awful thing, and I don't know why, but like every third person had asked for an access code, and something like that. It's about a third, maybe a fourth of the people. And what you have to do is you have to close the tab, reopen the tab, and then hope you don't get that 1 in 4 chance again. And then eventually, after doing it 2 or 3 times, 25% to a 4th power is small enough that it won't happen. Does that make sense? But if it asks for an access code, turn it off, turn it back on. Okay, so that's one. I'm trying to think of all the things people have trouble with, and that's one of the biggies is the access code. Okay, and then I email back saying turn it off, turn it on, and then I never hear from you again, which means it worked. Because if it works, you don't have to email me. I will be there at least for the first half hour. Usually after that, it's not an issue. But I'll make sure that I'm online, not on Zoom, because if you're on Zoom and Proctorio, it doesn't work. I'll be online checking my email for each of the 3 exam days for that first half hour at least, sometimes longer. But again, after half an hour, everyone's is in. And it's not an issue then. So then you can ask me questions and I can do my best. There's also a Proctorio help desk that you can get live help. And so if something goes wrong, then you can try that too. Okay, honestly, I don't like Proctorio, but there's just no other choice. Our college has it, which means you don't have to pay for it. And you know, it's the only way to make sure that there's honesty. Okay, that changes maybe even next quarter, but we'll see. Because what I usually do is have you take it at a library. But right now with COVID, I can't make you do that. So that will change. Any other questions about the exams? About just kind of the general piece of the exam? Okay, so the next thing I'm going to do is I want to talk about some of the details of the exams, but not all of them. So I'm going to talk a little less than you're used to, but I'm definitely going to tell you a bunch of stuff. Okay, so number 1 is the same honesty statement that you had to do on exam 1 and 2. Nobody had problems with exam 1 and 2, so hopefully you won't on this one. So the idea is, you know, no cheating, basically. If you have adults in your, where you live or where you're taking it, let them know not to talk to you. If you have children, you can help children out, because I think I would be evil if I said you're not allowed to help your child. So I don't do that, but adults are different. Okay, and then 2 through 7 are true false questions. You're used to those because exam 1 and exam 2 had true false questions. So did most of your online assignments, your chapter assignments. Okay, I'm sorry, 8 through 15 are true false. 2 through 7 are find the correct test or interval. And I'll show you more detail in a little bit. So what that is I give you a scenario and you have to choose the right hypothesis test or the right confidence interval to use so that you would know how to start if you were to do it. Okay, I find that the most important question in the whole class, because if you don't know how to start, it's over for you, right? So whereas, you know, when this class is over, say, you know, 6 months from now or 2 years from now, if you know how to start and you know you need to do, you know, say a chi-squared homogeneity test, and honestly, I'm sure 2 years from now you'll have forgotten what it's all about. But then you can go and look it up. The book is open forever, okay? And there's a whole lot of other resources online and you can look it up. But if you don't know how to start, you're gonna have to read the whole statistics book instead of go to one little thing and go look it up and do that test. So my feeling is this 2 through 7 is a biggie. And that is just to say what test or what confidence interval you have to do, and then you move on. And it's just a click. It's a multiple choice, but it's a very long multiple choice because you have a lot of different kinds of confidence intervals and hypothesis tests. And I'll show you what it looks like in a bit. Okay, then everything else. So again, the problem with telling you individually is that we've had a whole lot in this class. And what would happen if I asked you one of each kind of problem? Any guess?
It would take forever.
Yeah, even worse, you only get 2 hours. You'd only be able to do a third of the test and you have to leave the rest blank and you'd all fail. So I can't do that. So I do want to apologize if your favorite type of question is not in the test. Sorry about that. I don't know what everyone's favorite is, but I can only do, you know, a scattering. I will tell you a few things though. That is, it is heavier weight on the stuff you've not been tested on yet. So do you remember where exam 2 left off? What chapter? for what concept?
I think it was chapter 9.
Exactly, chapter 9. So I will tell you there's a heavier weight on 10, 11, 12, and 13 than there are on 1 through 9. There are some problems from 1 through 9, but expect at least one problem from each of chapters 10, 11, 12, and 13. Okay, so this is why I can't tell you, like I did before, where problem number 16 looks like this, because then you'll know what you don't have to know, and you do have to know everything we've done in class. This is a comprehensive final, so I'm not going to tell you that you don't need to know this particular type of confidence interval, even though I'm not testing on it, because I want you to study for all of it so that when you get to whatever you need, you'll know how to do it. So, but I will guarantee that you're going to have something from chapter 10, and that's 2 proportions or 2 means. You're going to have something from chapter 11, and that is a chi-squared, whether it's goodness, fit, homogeneity, or independence. I will tell you, you're not going to have all 3 of them because that would take too much time. And how many questions are, actually, I don't remember, but honestly, that shouldn't matter for your studying, right? That shouldn't make any difference on like how you're going to study, because I'm not telling you what isn't on the exam. So it's not an important thing, even though you might be curious. Hopefully you agree with me that that shouldn't make any difference. From chapter 11, I won't tell you, but it's going to be either homogeneity, goodness, or fit, or independence. And I could ask you up to 2 of them. I won't ask you all 3 because that would take too long. Okay. And regression analysis and ANOVA. Okay, so make sure you practice those for sure. I would start there. So I would start chapter 10 through 13 because it's heavier weighted because you haven't been tested on it yet. Any questions on that idea? And also, if you know, if you know the stuff, you can do the rest for most of it, except for the very beginning stuff. Like if you know hypothesis tests for two variables, then you should be able to do hypothesis for 1 variable. And if you know confidence interval for 2, you should be able to do confidence interval for 1. You know what I mean? So you don't need as much practice. You just have to remember like paired versus not paired, or dependent versus independent. The earlier stuff, that you'll have to do some extra practice. So what is the earlier stuff? Let's see how good your memories are. What are some of the big concepts? Pre-hypothesis test and confidence interval.
Probabilities,
Good, probability. And there are a lot of types. There was a chapter 3 probabilities.
central theorem.
Yeah, let me talk about probabilities first.
Okay.
Then we'll get to the others. One thing at a time, you know how it is. So the probabilities. So that would be chapter 3 kind of probabilities. I could give you a a long sentence or 2, and then say find the probability of. I could give you a table, and I could say find the probability of. I could have things with and or givens in. Do you remember those words? Okay. I could give you rule of complements, multiplication principle, independence, mutually exclusive. Remember all that stuff? So any of that's fair game. I could give you binomial probability. So now we're in chapter 4. I could give you a uniform distribution probability. So probability is huge. Probability is most of the rest of the class, most of the pre-confidence interval stuff. I could give you a uniform distribution question. That's a probability. I could give you a normal distribution. That's a probability. I could give you, as you mentioned, a central limit theorem problem. That's a probability. So the word probability is a huge word. So are you going to be tested on probability? What do you think the chances are?
100.
100%. Okay. And in fact, more than 1, because like that's everything before chapter, before the chapter 8. Okay. I guess to say chapter 3 through 8 is all about probability, right? Okay. So that was all the probability stuff. What about chapters 1 and 2? Do you remember what those were about?
Was one about terms?
Yeah, one was a lot of vocabulary, and also about how to do proper sampling. Yeah, sampling techniques. But I will tell you that won't be in the past problem 15. Those will be more in the true false questions. Because terms I can ask with true falses pretty easily. So expect some. That makes sense? They're not whole long problems. Those are quickies. But if you don't remember the word, then good luck. Or if you put it on your note sheet, but you don't understand your note sheet, that's not going to help. Okay. So don't assume that if you wrote it down in your note sheet, you don't need to practice. Okay. You should also remember Z-score, for example, and outliers. So I'm going to mention some other things that happen. Quartiles, so statistics, that's a chapter 2. So you should remember all the chapter 2 stuff. We've done a lot in this class. Standard deviation and standard error, very important. Remember what they mean, how to interpret them, that kind of stuff. You should remember how to read charts. Yeah, so that's like histogram, stem and leaf, box and whiskers. Those are the 3 main charts that I would test you on. If there's going to be a chart question. Any questions on the content of the test? Okay, we've had a lot in this class. This is not, I don't consider this a light class. Okay, I don't sit around saying, well, I really have nothing to say because we have no more content to talk about, so I'll just BS. I don't do that because there's always stuff to say, right? So this has a lot of content. So you need to practice. All right, so now that I said you need to practice, now let's go back to practice. So now let's go back to the main page. And we're at the end. And if you go to comprehensive final, oh, this is a past structure. I'm going to remove this because I don't want to confuse you. That was a structure for like a lot of years ago. Got to remember to do it in the other class too, but I'll remember. Okay. But what I have done is I've created some applets. As I think you know by now, I'm a programmer, right? So if you click on this review applet page, click on links to external site. This gives you some applets. And unfortunately, this you don't know how sad I got. A lot of the applets I wrote in Flash. Do you know what that means? Do you know why I'm sad? Flash got discontinued as of 2021. That sucks. So any of them that don't say new, if it says Flash, don't even open it. It just won't work. Sorry about that. But in comprehensive review, see this practice classifying statistics problems? Here's what you want to do. You want to click on this, and this uses JavaScript. So this will work even on your smartphone. Okay. This is the first questions. Questions 1 through 7, I think it was. So what do you think we need to practice? Which of these lists do we think we need to practice?
All of them.
Exactly. So select all. You're going to want to select all and hit submit. Any questions so far? Okay, then what it'll do is it'll give you a paragraph. Let me just read 1 or 2 of these. How much more likely is it that a startup restaurant will last for at least a year when it is part of a larger chain compared to one that is a non-chain restaurant? 100 startup chain restaurants and 80 startup 100 startup chain restaurants and 80 startup non-chain restaurants were observed for a year. So then you have to decide which of these many things it is. See if anyone knows. I'll click the first one that pops in the chat box. You don't have to get it right. On the final, you want to get it right. Here you just want to try. So don't spend too much time on it for now.
Would it be confidence interval for the difference between two proportions?
Okay, let's try it. So confidence interval for the difference between two proportions. So let's click it. See that little happy face? That's a good thing. That means you got it right. Okay. Then you go next question. So are women more likely than men to ask directions when they're lost? 43 women and 72 men were surveyed.
Would it be hypothesis test for the difference between two proportions?
Let's try it. That's right. Awesome. 2 for 2. So if you're 2 for 2, should you say, I got it? I don't need to study anymore?
No.
No. No, you want to do this for a while. You know, if you can get 10 in a row right, you're probably done. But these could get hard. If you get it wrong, so let me show you what happens if you get it wrong. Let's suppose you thought it was a hypothesis test for the difference between means, independent. It'll give you a sad face. And it says the variables are not quantitative. So it gives you a hint. Doesn't tell you what's right. It gives you a hint so you can try again. It guides you to what you've made a mistake on. Okay. We have a yes or no question. Please try again. And then hopefully you remember yes or no questions are about proportions. And that would guide you to proportions. So I created this. This has turned out, and I never know when I create something. This turned out to be my most popular app that I've ever written. Over 10 million people have used this. So it's just blew up, especially, you probably would never guess, high school kids that are taking AP stats. This has become the AP practice for America. It's kind of cool. So, but also college people. And when our server goes down, I get so many emails from all over the world. It's a little weird. And I have to apologize, say, wait. And I made a backup copy on LibreText. Any questions on this practice? So again, you want to do them until you're just getting them consistently right, and then move on to the next thing to study. Okay.
I have a question how we get there. It was review applets, and then what was the next one?
Yeah, so let me hit the backspace. I think it's probably best.
Practice.
So when you see review applets, you'll see practice classifying statistics problems. Okay. I also did a practice true false. I think I've shown this one to you, and you can do all and submit. Decide whether the following is true or false. For a binomial experiment with 20 trials, the probability R is less than 4 is equal to the probability R is greater than 16. True or false? Got a 50-50 chance if you have no idea. And by the way, don't leave anything blank on the test, because you get a 0 if you leave it blank. Better to get a 50% chance of getting it right. What do you think? I see true. So let's go true. Okay, no. So let me, so again, it's good practice. It's definitely not true. Here's the reason. The reason, and again, if you read it, don't just look at the unhappy face and go to the next question. Make sure you read the reason. So this would only be true if the probability of success were 0.5. So let me give you an example. Let's suppose we did a binomial experiment and we asked 20 people a yes/no question. And that yes/no question was, Have you been to Somalia? Do you think the probability that you're going to get, and let's say people, Americans, we're going to ask 20 Americans. Do you think the probability of getting less than 4 is the same as the probability of getting more than 16 people saying, yes, they've been to Somalia? No, probability less than 4 is really high because most people have not been to Somalia. Okay. By the way, I highly recommend not going to Somalia. They tend to kidnap Americans and do bad things. It's not a stable country.
So R is the number of yeses.
Yeah, R is the number of yeses. Sometimes use R, sometimes use X. So the point is that it wouldn't be the same. Okay. Had it been a normal distribution with mean of 10, then it would be the same, but not a binomial. Any questions on that? Okay, I'm not going to do all these, but again, you can practice lots of them. There's hundreds of these that I programmed in. I wrote them a long time ago. Some of them may not be relevant because it might have been before, when we talked about other stuff, but most of them should be relevant. Any questions on that practice applet? Okay, so just a note. Let me go back. So I want to show you all the different things you can do to study. So this one, the warning I'm giving you on this one is click it, but don't get scared. I'll show you why in a minute once I open it. So what I did is I created a list of past exam problems that I've given, not Canvas problems because this was pre-COVID. So these were written problems. And you're going to notice that there aren't just a couple. Hopefully I got the right one. Might have to refresh, redo this one. I shouldn't say exam 1. I'm not going to show you all of them because it takes forever. There's around 200 pages of questions. So you have a lot of questions to practice with. Okay, and I put this in Google Doc. There's no key to this because I want you to practice. And on the exam, you're not going to get the answer. It's not going to show, there's no button to see the answer on the exam. So this is a practice on what an exam will look like. Does that make sense? Okay, so that is another place you can find practice problems. All right, so that's a few. Let's go for more. Because the best way of doing on this final is to practice. That's number 1. There's also a practice final. This was written before COVID, so this was a written test. Sorry. And this gives some examples, but you'll see this has some matching ones. It has some true falses. It has all kinds of different things. Regression analysis, lots of stuff. Any questions on that? So that's another place where you can find some practice. There are a lot of practice. A good thing I've been teaching this class so long that I built up a lot of things that you can practice with. And so I think that might be all the ones I've got in there. Yeah, that's what I've got there. So the next thing, that's fine. The next thing is you can review stuff. What else can you practice?
Assignments.
Yeah, you can redo the assignments, okay, in practice mode. You don't get points for it, so there's no stress, but you can redo it. What else? Any thoughts? Besides the chapter assignments? So let me show you an example. You could do, say you wanted to.
Discussions.
Yeah, you can go to discussion. Say you wanted to practice the confidence intervals. And I don't know, for the single meet, you can go back to the discussion. And you can redo it. Okay. I recommend not just reading what's written. Reading is not helpful for practicing. What's better is look at the article and then try to do it yourself and then read it to see if you did it right. Does that make sense? Same thing with the regular chapter assignments. Don't look at the answers and do multiple choice and click. Write it out and then read the multiple choice. It's much better. And then you'll be ready, because that's what you're going to have to do on your exam. Is you're going to have to write down a full hypothesis test and with all the steps. You're going to have to write down a full confidence interval steps. You're going to have to write down a regression analysis with all the steps. Any questions on that idea? Okay, so there's a lot you can do. I'll also tell you that I'll be around. You know, given the, you know, we don't get some horrible snowstorm that closes internet. I'm pretty quick to respond. You can post in the Q&A board now. And I check it several times a day. Okay, not every minute of the day because I have other things in my life, but I check it several times a day, and I answer. So I'll answer it with a, you know, full discussion. If you have a question about a problem, don't just say problem 4. It's better if you can copy and paste the problem into the Q&A. Okay, that works better, especially if you're doing a, say, a chapter assignment, because problem 4 is not the same each time you do it. Okay, so it's 10:33, which is about time. So what I'm going to tell you is that we're done. Okay, you're not done with the class because you still have the ANOVA, you have your, you can have a secret word quiz, and the main thing is you have a final exam. But there's nothing left to talk about in terms of statistics. I'm going to stop the share. And thanks for a good class. Hopefully I didn't torture you too much. And hopefully you learn a lot of statistics, because that's the whole point. But I'm going to stop recording.